This video is on programming the AR4 robot. So at this point you have already gone through the AR4 startup video, you have your robot commissioned, and you have the AR4 software open and running. So let's start out with jogging. Up here in the upper right, this panel of buttons is for jogging the robot in joint mode. Each joint has a window that tells you the current joint position. It has a button for negative and a button for positive, and it has a slider. So if I press the negative button, the joint will move in the negative direction. If I press and hold the button, the positive button, it will jog in the opposite direction. And then there's also a slider, so you can position the slider wherever you want the joint to go. So just a little demonstration there of jogging in joint mode. Now directly below that we have the X, Y, Z, yaw, pitch, and roll buttons. These are for jogging in Cartesian. So the X plus will move the robot forward in the X direction. X minus is back. Y will take the robot side to side. And then Z will obviously take it up and down in the Z direction. And then you've got the yaw, pitch, and roll, which changes the wrist orientation in any of those directions, as you see there. Now the next set of buttons below that is, it has a T in front of the Cartesian coordinate. So this is T is for tool, for jogging in the tool coordinate frame. So that means we're jogging according to the gripper. So if I jog in TX, that means the gripper, the X side, or the horizontal face of the gripper, is going to move in the X direction. So when I move there with TX positive, you can see that the face of the gripper, the robot is going to jog up according to the face of the gripper. In the Y direction, it will move according to the side of the gripper, and move along that axis. And then the Z will basically dive the gripper in and out wherever it's pointed. And kind of demonstrate that, I'll move joint 5 a little bit here. So let's point joint 5 down, and now when we jog in the Z, you can see it's jogging according to whichever direction I've pointed my gripper. So that's the tool jogging. We also have, for jogging, we have incremental mode. So right now, everything I've shown you has been in analog mode. If I click this button, we're now in incremental mode, and it will jog according to the value in this box. So right now it's at 10. So if I'm using any of the Cartesian buttons, it will jog in increments of 10 millimeters. So if I was to jog up in the Z direction, every time I click the button, it's going to move 10 millimeters. Or forward in the X, it's going to move 10 millimeters. And if I'm using joint jog, that value is in degrees. So if I was to jog joint 1, it will move 10 degrees in incremental mode. Now you also have the speed value. Right now we're at 25%. We could run that all the way up to 100%. And then you can also change that from percent to seconds. And so that means the move would take however many seconds you had in this field here. So if I wanted the move to take 5 seconds and I taught a move, it would move according to the value that I have set here for seconds. And then you can also set millimeters per second. So that means the robot would jog in a value of millimeters per second. So if I put in 10, the robot would jog in 10 millimeters per second. And then we also have the acceleration, the deceleration, and the ramp. So this controls how quickly it accelerates to speed, how quickly it decelerates, and then how fast it ramps up to that speed. So you can play with those values there and see how those affect all of the the robot speed and jogging and running programs. So next, let's talk about the Xbox controller. The functionality is fairly basic, but it does allow you to jog and teach positions using a wireless controller, which lets you get closer to the robot and what you're doing if you're not close enough to your keyboard. So I have an Xbox controller, and I have the the Xbox wireless USB adapter plugged into my computer, and the Xbox controller is installed and online. So in the software, I can come over here and click the button for Xbox on, and it will say that it's on, and it says it's jogging joints 1 and 2. Now the Xbox controller jogs the robot in increment mode only, and you can see it defaulted here to the value of 5. Now if I on my controller, if I press the right bumper button, you can see that that value increases by 5 each time I press the button. So I can increase the increment value, or I can decrease the increment value using the left trigger, and when I get down to 5, it'll go in increments of 1. So it gives you the ability to change your jogging increments. And then the speed, the bumper buttons up here, if I change the bumper buttons, you can control the speed while you're jogging the robot. Now it says here we're jogging in joints 1 and 2. So to change the mode, the X button will change it from joints 1 and 2 to joints 3 and 4 to joints 5 and 6. So you can see up here in the message here that tells you which joints you're jogging. So each time I press the X button, it changes the mode for which joints that I'm going to be jogging using the D-pad here. So if I change it to joints 1 and 2 and I press left on the D-pad or right on the D-pad, I'm controlling joint 1, and if I press down or up on the D-pad, that's joint 2. And if I change to 3 and 4, then I'm jogging joint 4, and then up and down is joint 3. And then when I press the X button again, I change to 5 and 6. You can see there I'm jogging joint 6, and now jogging joint 5. So the X button controls jogging in joint mode. If you use the A button, that'll switch us to the X and Y directions. So now when I use the D-pad, I'm jogging in the Y direction when I go right to left, and I'm jogging in the X direction when I jog up and down. And then when I press the A button again, that'll toggle me to the Z axis, as you can see there in the message. And now I can jog the robot in the Z direction using the D-pad. And then the B button puts us in the mode for the yaw, pitch, and roll. So we can control the yaw, pitch, and roll of the robot using the changing it to that mode using the B button. The Y button lets us teach a position, so we'll go over a little bit of that later as far as the functionality here. But if I'm on a joint move, for example, and the robot is in this position and I press the Y button, it will add that move, it'll teach that move. And then the start button controls the gripper open and close. So on your inputs and outputs tab, whichever one you have your first I/O set to. In this example, I'm set to input and output 8 for my gripper, and I don't have my air compressor hooked up at the moment. But if you press the start button, it would control that output to toggle the gripper open and closed. So next, let's talk about loading programs and creating programs. Up here in the program window, you can see that I already have the program home loaded, and the home program is just a single move that takes the robot to this L-shaped pose that you see here with all joints at a 0 value. You could also load in, for example, another built-in is the rest program, where we load that, and that takes the joint 3 to 89 degrees. It takes the robot to a vertical position where you power it off. We've also got some other built-in programs that you've seen, the test encoders and the test limit switches from the startup video. And then if the program doesn't exist, all you have to do is type the name in for whatever you want. For example, if I wanted to create a program called main, I could just type that in and hit load program, and it'll create it. It creates kind of a blank slate here. It keeps the comment at the top, beginning of program, and starts out with just a tab number 1 is just the default for a blank program. If you open up your directory where the AR4 software is, the AR4 HMI software, you can see all your programs are here. So here's the main program we just created. So every time you create a program, it'll show up here, and you can come here to delete them, to delete any programs that you don't want anymore. So next, let's just talk about building a real basic program, putting some moves and some commands into our window here. So from this drop down right here, we have the move types that we can select from. So right now I'm just going to go over a couple real basic moves. We'll talk about a joint move and a linear move and a move in the rotation of joints. So we'll just talk about those three right now, and we'll come back to the offset J as well as some of the other position register related moves in a few minutes. But a move J is just a joint move. That is a move of all the joints working together. That's not necessarily going to execute a perfectly straight line. It's just going to move to the position you've asked for using all of the joints. So right now that's what's selected. So I'm going to hit teach position, and it's going to create that move in a line here. And then let's say that we want to create another move after that. So let's move joint 1 and joint 2 and joint 3, and then we will teach another move. And so now I have two moves in my command window. So if I select the first one and hit forward, it will move back to that position, and you can see it's kind of a sweeping move. It's not necessarily moving the robot in a perfectly straight line. You can hit forward again and re-execute that position. Now let's say we wanted to make a linear move where the robot would move in a perfectly straight line. So let's jog the robot forward in the X direction, and then we'll change our move type to a move L for linear and place a move L in the program. So now I can go back and re-execute joint move to that position, and that's just a kind of a sweeping joint move back to that position. And now when I execute a move L, that's going to move the robot in a perfectly straight line along that path. So that's what a linear move is. And then the other move that I wanted to talk about right now is a move R. That stands for rotation, or rotation of joints. So I can select that, and when I teach a position, you can see here, rather than storing it, for example, this one stores the a linear or a joint move, shows the X, Y, Z, yaw, pitch, and roll Cartesian coordinates of the position. A joint move puts in the value for joint 1, the value for joint 2, the value for joint 3 and 4, and so on. So that would move to that position simply in the joint values for where that joint is. So another thing I wanted to cover right now is the manual program entry field and how that works. So I can come select any line. So I'm going to grab that move R, and I'm going to hit get selected, and now I can edit that line here. And so for example, for joint 1, let's say that I want joint 1 to be at 0. I can make that a 0. For joint 2, let's also make that a 0 value, and we'll just do that for all the joints. So now I have this in my manual program entry field box that's been changed, and I can come down here and I can either replace that line with my new line, or I can insert it below. So I'll insert it below, and so now if I execute that line, that will take all of my joints to a 0 position. So this just gives you a way to, to specify a move in which joint rotation that you want. As far as the program entry field, this comes in handy. If this move, for example, let's hit get selected on that again. Another thing in here is we have a little asterisk in between the brackets there. That's simply there as a placeholder for you to give the position a name. So I could call that position home, for example, and then I could I'll hit replace, and I will replace that line. So now in my code, I can give my positions names so that as I go through my code, I can quickly see, a name that tells me what that position is. And then using the manual entry field, I can also use it to insert that line anywhere I want. So if I wanted to, add my home position in multiple places in the program, if I wanted to start up here right below tab 1, I could hit insert and I could put my home position here, do some other motion, and then come back to my home position there. So that's how that entry field box there works. Now you can also modify positions and delete positions from your program window here. So if I wanted to delete a position, let's say I wanted to delete that one, I just highlight it and click delete. We'll delete that one as well. And then if we wanted to modify a position, for example, right now we have this rotation of joints move that we've called home, and they're all at 0. Let's say, for example, that I jog joint 1, and then I can hit, as long as I'm still on move R, I can hit modify position, and it just modifies this position to have the new value that it had before. And obviously we'd have to recomment it and give it a new name. But it makes it so that it doesn't have replicate another move that has the same name in it. Another thing that you can do is call a program. So let's say, for example, we wanted to call the home program. I can type in home and hit call program, and it will call the program home. So now if I was to execute that line on call program, it moves me into the home program, and then I could execute that move to go home. And so now we're home. Now, if I want this to go back to the previous program where we came from, it has to have a return at the end of it. So if I put a return at the end here and I execute that return, that will take us back to where we came from the main program. So anytime you call a program, that program that you called needs to have a return at the end of it. And you can only go one layer deep, so you would only want to call programs from this initial program that you started. If you called home and then tried to call another program from home, that would not work. It only lets you go one layer deep on that. So next, let's talk about arc moves and circle moves. Here from our move type drop down, we've got you've got move A and move C. So I want to talk about those next. So in our example here, I just got a roll of tape on a box. So give us something to use for an example. Let's start out with, I'm just going to teach a joint move that's in the position you see here that is above the roll of tape. And then we need to make a starting point for our arc. Let's start out talking about an arc. So I'm going to jog the robot down. And too far there. Let's just start there. So let's call that our starting point. So we need to teach a starting point. So I will just do a move L and teach that position. So that is our starting point of the arc. Then we need a midpoint and an end point for an arc. So I am going to jog the robot. Let's go forward in the X, and then let's come over in the Y to the edge of the roll of tape. And so we will teach that. That will be our midpoint. So we'll do an arc move, midpoint, and we'll teach that position. And then let's jog the robot forward, and then we'll come back in the Y a little bit, and we will teach that as our arc endpoint. And then we'll execute through these moves. We'll go back to our starting point that's above, and then we'll execute the start point for our arc. And then when we hit forward on the execute for the mid and the end, it will execute both of those together, and we'll execute our arc move, which goes in an arc around the tape as you see there. So now let's talk about doing a complete circle. I'm going to go ahead and delete the arc moves there, and we'll move back to our starting point. So now for a circle move, we need a center position, a start position, and then we need to know what plane that we're on to do the circle on. So let's start out with the center position. So I'm going to jog the robot, and I'm going to put the pointer in the center of that roll of tape. Okay, so let's call that our center. That's pretty close to the center of the roll of tape. So we'll teach that position. So that is our move C center, and then we need to jog to our starting point of where we want the circle to start. So I'm just going to jog straight back to the edge of the roll of tape, and I will teach that position for our starting point. And then it needs to know what plane and space that it is, because it could make this circle on any angled surface. So it just needs a third point, and that can be just any other point on the roll of tape. So I'm just going to jog to the side a little bit, and we'll just call that good for our plane. So that's on the same plane that we're on. We could teach that position. So now I will execute that position, and then when I execute the move C center, I'll execute all three of those together to run our circle. And that's how the making a circle works. So next I want to cover a little bit of registers and position registers, as well as the offset J move type. So if we go to the registers tab, you can see here we have 16 registers. These are just single integers that are used for counting. And then we have 16 position registers, and these are values that have 6 different elements, 6 fields for the X, Y, Z, yaw, pitch, and roll of a position. So if we go to our command window here, and we taught an offset J position, if I teach that, what you can see here is we have a position that is the X, Y, Z, yaw, pitch, and roll of our current position, but it is going to be offset by whatever is in position register 1 right here, and it puts that 1 in there by default. You can use any of the position registers you want. You could, for example, hit get selected and change that to position register 2, for example, and you could insert that in your code, and you could use as many position registers as you need. For right now, I'll delete that. We'll just stick with position register 1. So if I was to execute this, nothing's going to happen because it's at its current position where I taught it, and position register 1 is all zeros. Now, for example, if I took the third element, the Z value, and changed that to 25, for example, and then went back and now re-executed that line, the robot's going to move up 25 millimeters. If I go here and put in, say, 50 and execute it, it's going to move up 50. So now let's talk about how to manipulate position registers from the code. Let's say in our program, we want to start our program right under tab number 1, which is going to be the top of our loop. Let's say that we want that position register 1 to element 3, the Z value. We want it to start at a value of 0. So we've got position register 1, element 3. Element 3 is the third element, the Z value in that position register. And we are going to set that equal to 0. So I'll come right here and I'll put that in my code. And now when I execute that line of code and we come back here, you can see that's now a 0. So now let's say that we want that position register to increment or decrement by some amount. I can take And if I was to make that, let's say 10 millimeters, that would just statically set the value to 10 millimeters every time the line of code runs. But let's say I want it to increment by 10, I would put two pluses in front of it. I do plus plus 10. And so now if I put that line of code here, it will increment by 10 each time. So if I hit forward on it and come look at it, now it's got a value of 10. If I execute it again, now it's 20, and so on. So every time that runs, it's going to increment the value by that amount. And what this is, would be used for is for stacking. For example, if you had a pick routine, you go pick apart, and then you come back here, and every time you place it at this position, it's going to place, one height higher. So let's say we wanted to run this in a loop. We haven't talked about the tabs yet, but we have tab number 1 here. If I do jump to tab, if I'm going to put value number 1 right here and put jump to tab 1, now every time I execute that, it's going to jump back to the top. But then, of course, it's going to set that to 0, so I just screwed that up. So let's take this value and let's do get selected, and let's put it above that. So let's insert it there. And then below our tab, let's delete that. So now, when we start our program, at the beginning of the program, it would set element 3 to 0, and then we're at tab number 1. So now, if I hit play, it's going to move to this position, increment the amount, and then jump back up top. And let's also put a little wait time in there. Let's put maybe 1 second so it's not moving too quick, so we can see the pause in between each loop here. So we'll put a wait time of 1. This is in seconds. You can put any value you want in there. So let's start at the beginning and hit play and see what happens. So every time it runs, it's going to move the robot up 10 millimeters. Now it's just going to keep going until we get a join out of range error. So I'm going to hit stop right here. So that brings us to registers, for counting registers. So let's say we didn't want that to keep moving up indefinitely. We only wanted it to move up, let's say 5 or so times. We could use one of these registers to count for us. So what I could do is I could come up to the beginning of our program and I could say register 1 equals 0, and I'll put that at the top of our program, and that'll reset that register to 0 every time the program runs. And then let's say down here, after we've moved up, we want to increment register 1 by a value of 1. So I could hit plus plus 1 there, and now every time this loop runs, that register will start incrementing and counting. But then we want a way to stop after that register gets to, say, a value of 5. So let's go right up here to the top of our loop, and at the very top of our loop we'll say that if register 1 equals 5, then let's jump to a different tab. Let's jump somewhere else, and we'll jump to tab 2, which we haven't created yet, but we will here in a second. So I will put that right here. So this will evaluate, once that gets to 5, it will jump to wherever tab 2 is. So I'm going to come down here and I'm just going to create tab 2, which will just get us to a different place and out of our loop in the program. So tab number 2 will be the end of our program. And another thing that I didn't talk about was comments. You could use this manual program entry field to put comments in your code. So let's you can put any comment you want as long as it's not a decipherable line of code. So I usually just put in some hashtags, and let's just put in a comment that just says end of program. And we will put that, we can just put that right before tab number 2, and we can just insert that right there. So that kind of tells us that that's the end of the program when it gets to tab number 2. So now if we come to the top and hit play, what's going to happen is we're going to reset all of our registers. We're going to reset register 1 to 0. We're going to reset our position register 3 to 0. Then we're going to start at the top of our loop, our tab number 1. We're going to evaluate our register 1. When it gets to 5, we're going to be done and we're going to jump out. But then we're going to start, we're going to move to position. Then we're going to increment the position register by 10. We'll wait for a second. We'll increment the register that says, yeah, we've done it one time, and then we'll jump back up to the top, and we'll just keep doing that. And when it hits this, if register 1 equals 5, it'll jump to the bottom and end. So it should only move up 5 times. Okay, so there you can see it stopped after 5 loops. It only moved 4 times, I apologize, but you can see how that worked there, that it stopped after it went through the loop 5 times. So now let's talk about the remaining position register functions down here. We've got move to position register. That is very similar to the offset J, where if I choose move to PR and hit teach, it basically the robot's just going to move to whatever value I've put in position register 1. We've also got teach position register, and what that does is just populates a position register for you. So if I hit that, that's going to add 6 lines of code that will put the current position of the robot, which you see here, each of the current positions, it's going to put those into a position register. So if I execute all of those lines, and then I look at my registers, it's put our current position into position register 1. So now we have our current position. So this might be how you would teach your, say, your starting position for a stack, for stack of blocks, for example. And then the other function we have on here is to move offset of a position register. So if I select that, it's going to take whatever register I put in here, and it's going to offset it by the next one. So if I put 1, it's going to offset 1 by 2. So let's do that now. I'll come right here, and actually before we do that, let's just put in some blank comments just to give us a little space so it makes it a little more readable. And so I'm going to insert a couple of lines there, and then let's put that right there. So now what we're going to do is we're going to move offset of position register 1 by whatever's in position. We're going to move to position register 1 offset by whatever is in position register 2. So if I was to execute that right now, it's not going to do anything. It's just going to move to where it's currently at, because what it's doing is moving to this first position register offset by whatever's in position register number 2. Now if we wanted to do an example where we were going to stack and move upward and then do a second row, we would, kind of similar to the last example, let me move the camera over here out of my way a little bit. What we could do is we would say that we would take position register 1, element 3, and we will offset it by 10, increment it by 10 like we did last time, and we could place that right there. And so now when I execute that line of code, it's going to increment the value by 10, and so now when I re-execute this row, the robot's going to move up by 10. And so every time I do that, the robot moves up by another 10, very similar to what we did in the last example. So let's do the same thing where after 5 rows we jump to a separate set of code. So up here in our first portion, let's take counting register 1 and 0 it to 0. So now at the beginning of the program, we're going to set our position, we're going to reset that register to 0, and here in our code, let's increment it, do ++1 each time. And so now we're going to move up by 10, we're going to increment our counter, and then we need to jump back up here. So let's put in create tab number 2, and let's create that up here, and this is going to be the top of our loop. So let me just put in a comment that says top of loop, just to try and help keep this readable. So this is the top of our loop, tab number 2, and then let's create a jump to tab number 2. So now it's just going to keep running through this and moving up by 10 each time. But what we want to do is we want to go somewhere else once it gets to 5. So we're going to say if register 1 Let's just do 6 this time. If it equals a 6, let's go to tab number 3, which we haven't created yet. Okay, so this is going to run through and loop through and climb and keep moving this register up by 10 until it gets to till register number 1 gets to 6, and then it's going to jump to tab 3. So let's come down here and create a few more rows just to give us a little bit of space. And then let's call this shift rows code. So down here is where we're going to want to shift our row to the next row. So what we can do is, since we're moving to position register 1 offset by what's in 2, we want to take position register 2 and we want to take the Y value, element 2, and let's say we want to increment it by 25. So each time we get to this shift rows code, we're going to shift over by 1 row. It's 25. Now we also want to make sure that our height goes back down to the table, to the starting point, so we can come grab this line, which is our position register 1 element 3, which we've been incrementing by 10. We want to set that back to where it's at. So I'm going to hit get selected, and then I'm going to insert it right below that line right there. So now we've started at the bottom layer again, but we've moved to the side by 25 millimeters. And then the other thing that I want to do is I want to take register 1 and make it equal to 0 the same way we did up here. So I can come here and say position register 1, or not, excuse me, register 1 equal to 0. I can place that here. So now when I get to this shift rows, I'm going to shift to the side by 25. I'm going to reset my Z height. I'm going to reset my counting register, and then I want to jump back up to the top of my loop, which is tab number 2. So I'm going to do a jump to tab number 2. So now when I run this code, it should do a stack of 5, move to the right, do another stack of 5, move to the right, and keep. And there's one thing I forgot to do here. Our shift rows code, I forgot to put a tab here to jump to, because when we get to 6 high, we want to jump to tab 3, and I totally forgot to put a tab 3 there. So let's create tab number 3 and put it right there. So now our shift rows code actually has a tab to go to. So now if we come to the top and play this code, it should do a row 5 tall, come down here, shift to the right, reset everything, come back up, and do a stack of 5 again. So let's see how that works. So you can see each time it gets to that shift rows code, it moves over by 1. So now we've done 3 stacks, and now we're moving to a 4th stack. So it kind of gives you a little bit of an idea of how you can use these position registers to manipulate position. And you could keep moving to the side, you could move front to back, however you need to manipulate the position registers. So a few of the other buttons that we haven't covered yet, we have wait input on and wait input off. We have the set output on and off, and we have the if on jump and the if off jump. So all of these are related to I/O and inputs and outputs. And if you go to the tutorials page, I have a video called AR4 grippers and I/O devices, and I go into a lot more detail on these functions, on using I/O. And how it's wired to the board. So that video would be a good source to get more information on all of those functions, but they're fairly basic. You can obviously wait for an input to come on or off. You can set an output on or off. That would be how you would control a gripper. And then these would let you navigate or jump to different portions of the code if an input was on or off, to give you some options. For example, if you had a start button or a limit switch or something along those lines that you needed the program to jump to a separate set of code once an input was made. Also on the input output tab here, we've got some quick keys that you can use. So for example, output 8, I could just toggle the gripper open and closed using output 8, which is the one that I've wired it to. I could also control a servo put in the servo value and control the servo, which is also covered in the gripper and I/O devices video. If we go to the config setting tab, there's a few things on this screen. We've got the communication, where you would, as we covered in the startup video, where you'd set your TNC COM ports and you set your I/O board COM ports. We've got the 7th axis calibration. So in these fields, I would put in the length of my track. My track right here is 340 millimeters. We want to put in millimeters per rotation, so it's a 1 to 4 screw. So it's for every 4 rotations, it moves a millimeter. And then my drive steps, it's set to 200 steps on the DM542 stepper driver. So I can put in all these values, and I can calibrate the track to 0 using this button. And then on the main control screen, we have our 7th axis control here. So that would allow me to jog the robot to one side or the other. And the track jogging is in incremental mode there. And then I could also use the slider to move the track to whatever position I wanted it to go to. And then we've also got these 2 small buttons below, and I just threw those in. That allows you to jog the track but keep the tool center point in the same spot. You can see there the base of the robot's moving, but the gripper's staying in one place. So it's just something to move the track if you want to move the base of the robot but leave the gripper in about the same spot. Again, that's a joint move. You could teach a move L with the gripper in a fixed point in space and the track moving, and that would be a more accurate movement, like you saw in the initial release video. Going back to the config settings tab, we also have last command sent to controller and last response from controller. So if you were wanting to write your own software, use serial commands, this kind of spits out a readout of what the command was that was sent to the controller and what the controller's response was. It usually just responds back with, confirming its position. But it'll also, if there's any error codes or anything, those will be shown here too. So you can always see what the commands and responses are if you wanted to see that information. In this section, we have our joint calibration. We have the auto calibrate button, which will auto calibrate the robot, which we covered in the startup video. These checkboxes, you can select which joints you want to be in the auto calibration. Typically, you would have all 6 joints selected, but if, for example, you had a large end of arm tool that would hit the arm when calibrating, you could deselect 5 and 6, for example. Anything on this screen, if you've made a change, you need to hit save for it to take effect. And so now if I hit auto calibrate with 5 and 6 deselected, you can see it will run the auto calibration, but you can see axis 5 and 6 aren't moving, so that you could do the auto calibration for joints 1 through 4 and then come back and do joints 5 and 6 separately. So the auto calibration completed, but then if I wanted to do joints 5 or 6 separately, I could click calibrate joint 5 and it would just do 5 on its own, as you can see there. We also have force calibration to 0. That's if you're in a setup mode, you're setting up your robot, and you've jogged one of your joints off to one side, and then you've mechanically moved it, and you want to just put your calibration back to 0. This is just a button that would be used just for setup and testing and messing around. You have your calibration offsets. We covered a little bit of that in the initial release video, where if you calibrate a joint and it's off by some amount, if one of your limit switches is bent or you've got a limit switch from another supplier that is a little bit different and not giving you a perfect 0, you can come in here and manipulate these values and change your calibration value so that when you hit auto calibrate it would be correct. So it's just a fine-tuning adjustment on that. You've also got your encoder control here. You can select all of these to disable the encoder. So if you're having a problem with an encoder, or you need to do some testing, or you haven't got your encoders wired up yet and you want to test the robot, you can run in open loop mode and disable the encoders using any of those checkboxes. You've got your tool frame offset. Most of the time, all you would use is the Z value if you've got a long tool on here and you wanted to just manipulate the robot's known position of where it's picking and placing. It would just manipulate the XYZ value based on what tool value you put in there. And then we've also got the theme mode, the light and the dark. It's default on light. You could hit dark and it goes to dark mode. So you have the the dark mode as an option. And then the input outputs, we already went over that. We've gone over registers. The vision tab, this is just lightly developed. I have a video under the AR2 videos. If you look at the AR2 videos on the tutorials tab, there's a video called Programming Part 3, which goes over the vision control. So this just uses a couple of open source programs to put a position from a camera into a text file, and you can dictate where that text file is, and then it will put those values into position register 1 for you. Right here, it'll put it into the first position register for you. So it's not heavily developed, but there's a little bit of vision functionality there. And then of course we have the log that just keeps a running log of everything the robot's done, and then you can clear the log. Then we have an info tab that's just got a little bit of documentation on programming and such. So that pretty much concludes the programming for the AR4. Please email me if you have any questions. Thank you very much.